friends, I hope you all are doing well. In this video we will see how to design two-way slab using Excel sheet. So first of all we need to look at the problem statement. So there is a floor which is consisting of 15 slabs from first to 15. Okay. So as per the problem statement we have to design the slab S2 whose dimension is 3 by 4.5 meter, and this slab is supported by the wall of thickness 230 mm. The slab is subjected to live load of 2 kN per meter square and of floor finish as 1.5 kN per meter square. The material we have to choose while designing this slab as M20 for the grade of concrete and Fe415 for the grade of steel. One more thing is also given here, that is exposure condition, that the exposure condition is mild, and this will be required while deciding the covering to the slab. We will see later on. Now the first question is that we have to know which type of slab is this S2 slab. So S2 slab may be one-way slab or two-way slab. So how we can decide whether it is one-way slab or two-way slab? Obviously by the aspect ratio, that is Ly by Lx. So the Ly Ly, the longer dimension of this slab is 4.5 meter and Lx is 3 meter. Now if Ly longer dimension divided by shorter dimension is greater than 2, then the type of slab will be one-way slab. We all know. If Ly by Lx is less than 2, then type of slab is two-way slab. Okay. So how we can decide? So aspect ratio is very important. So first Ly by Lx for our problem, Ly is 4.5 meter divided by Lx is 3 meter. Now the value will be, if you calculate this ratio, you will get the value as 1.5. so that is less than 2. The type of slab is two-way slab. Okay, so it is clear that this the slab S2 is two-way slab. Now the next question is that which type of panel is our slab falls in which type of panel, because while deciding the designing this two-way slab we require to decide the type of panel. As per the IS 456-2000 page number 91, see here, so there are 9 type of panels, okay, based on the age condition of the slab. Like for example, in our problem there is a floor which is consisting of 15 slabs, as we know. So the first slab comes under the type of two adjacent edges are discontinuous. See, this is short edge this is long edge. Okay, this is short edge and this is long edge. This is short edge, this is long edge, long edge. This is also long edge, long edge. This is short edge. So these two edges are discontinuous. Okay, two edges are discontinuous. For example, we have to design slab S1. So while deciding the type of panel, we have to see two adjacent edges are discontinuous. See here, two adjacent edges are discontinuous. So we need to choose the movement coefficient from this this line. Okay, so likewise we have to decide our slab comes in which type of panel. Okay, this slab S2 is falls under the category of one short edge is discontinuous. See, one short edge is discontinuous. Again, one short edge is discontinuous, one short edge is discontinuous. If you see in code, one short edge is discontinuous, or we can say one short edge is continuous. Either we can say one short edge is discontinuous, or at the same time we can say one short edge is continuous. See, this edge is continuous. So what we can say, at first one short edge is discontinuous. At the same time, for the same slab we can say that one short edge is continuous. Okay, so same thing is here, one short edge is continuous. So second slab falls under the category of one short edge is continuous. Okay, and third, one short edge is continuous, and fifth slab will falls under the category of two adjacent edges are discontinuous. Okay, similarly one long edge is discontinuous, or we can say that at the same time one long edge is continuous, one long edge is discontinuous. This comes under the category of interior panel. These all are the interior panel. Why? Because it is supported from, it is continuous from all its four sides. This is also under the category of interior panel. Is one long edge is discontinuous or one long edge is continuous. Okay, so likewise we will decide the type of panel. So these two concepts are very important, type of slab and the type of panel. Okay, I hope all these things will be you understood. Now next we come to the Excel sheet. Okay, so first our type of slab is, see, S2 slab falls under the category of one short edge is continuous. So this is see, one short edge is discontinuous, we can say, or continuous. So second type is one short edge is discontinuous. Now as per, so we don't need to do anything at these points. This by default will adjust the values. Now the next question is shorter span. So shorter span is 3 meter and longer span is 4.5 meter. Okay, so the aspect ratio will comes out to be 1.5 and the type of slab is two-way slab. Okay, so Excel sheet by default will show the aspect ratio and the type of slab. Okay, and by default this Excel sheet will choose the moment coefficients. Okay, so you don't need to do anything at these points. Okay, we only need to concentrate on the yellow cells. Okay, now the grade of concrete. Okay, that is from drop down option you can choose the value. We have to choose the grade of concrete, that is M20, and grade of steel is Fe415. Okay, now diameter of bar for this slab. So as usual in most of the cases the diameter of bar for the slab is chosen more than 8 mm. At least 8 mm should be the diameter of bar for the slab, or it may be 10 mm, 12 mm, but don't go beyond the 12 mm. It's my opinion. Okay, so here we will choose the diameter of bar as 10 mm. Okay, now covering. As per the exposure condition in our problem, the exposure condition is mild exposure condition, mild condition. So as per the IS 456 2000, page number 40, I think 41. Okay, it is 47. As per the IS 456, page number 47, table number 16, for the mild exposure condition, the nominal cover that is to be considered for the slab, that is 20 mm. That's why we have taken the clear cover as 20 mm, and supporting width is 230 mm as per the problem statement. Okay, now the load calculation. The density of concrete is 25 kilonewton per meter cube. For the reinforced cement concrete, the density of concrete that we are taken, generally we consider as 25 kilonewton per meter cube. Okay, the density of brick we have taken 20. Okay, now at this stage we have to assume the thickness of slab. Later on we can make the changes in this thickness of slab, but at this initial stage we have to consider the trial depth of slab. So the depth of slab should not be less than 120 mm. Remember, the depth of slab for the floor should not be less than, depth of slab should not be less than 120 mm. Okay, that's why at the initial stage we will choose the depth of slab as 120 mm. Okay, now effective depth of slab in x direction, that is 95 mm, and effective depth of slab in y direction, that will be 85. How? So see, this is slab, and the main shorter span reinforcement will be provided at the bottom. Okay, and longer span reinforcement are provided over the top of shorter span reinforcement. So the effective total depth of the slab as 120. Now the effective depth will equal to at this point, so total depth minus clear cover minus half of diameter of bar. So this will be the depth in x direction. If you calculate this value will comes out to be 95, and effective depth in y direction will be equal to dx minus diameter of bar. If you calculate this value will comes out to be 85 mm. Okay, so try it on your own. Okay, so 95 and 85. The waterproofing and floor finish. Now the floor finish and waterproof cover over the floor we will consider as the thickness of the floor finish as 100 mm. Okay, now Excel sheet by default will calculate the self weight of the slab by multiplying the unit weight of concrete that is 25 multiplied by overall depth of the slab. Now if we calculate this value will comes out to be 3 kN per meter square. The waterproofing and floor finish will be equal to density of brick multiplied by thickness of the floor finish, thickness of TF. I call it as TF, thickness of floor finish. So if you take this product we will get the value of 2 kN per meter square. Okay, now the live load is 3 kN per meter square for the floor as per the IS 875 part 2. Okay, now the total load, the sum of these three values, 3 plus 3, 6 plus 2, that will be equal to 8 kilonewton per meter square. Okay, now if we take the factored value of this service load, that will comes out to be 12 kilonewton per meter 12 kilonewton per meter width of slab, what we are considering for 1 meter width of slab. Okay, now the next thing we need to find out the effective span of slab in x direction or as well as in y direction. So effective span is what? See, this is suppose clear span of 3 meter and 4.5 meter, and the support is the support is 230 mm. So the effective span will be from center to center of support, that will be 3 plus 0.23, so that will become equal to 3.23. okay, and this first criteria, and second criteria will be clear span plus effective depth. What? Clear span plus effective depth in x direction. So that will equal to clear span is 3 plus effective depth in x direction is what? effective depth in x direction, that is 0.95. The value will equal to 3.95 meter, and this first value suppose, and the second value is 3.23. 3.23. So we have to choose minimum of these two values, either 3.95 and 3.23. 3.095, so will be the minimum value. Okay, and likewise we will decide the effective span in y direction. Now the aspect ratio for the effective values will comes out to be 1.481. Okay, the next is maximum bending moment. So how we can calculate the maximum bending moment? That will be equal to, maximum bending moment will equal to alpha max multiplied by w factored value into lx square. So alpha max will be maximum of these four values. Okay, maximum of these four values will be alpha max. So Excel sheet will by default calculate the maximum bending moment and accordingly the depth required for the flexure. As per this maximum bending moment, how much depth is required for the slab, we will get from this, that is 48.98 mm. This that is about 50 mm depth is required for satisfying this maximum bending moment. Okay, so our depth provided is 95 mm effective depth. If we see, so 95 is greater than 48.98 mm, so safe, provided depth is safe in flexure, so it is okay for the flexure. Now the reinforcement. So for the slab, the minimum reinforcement to be provided in both the direction should be 0.12% of BD. So by default Excel sheet will show the minimum reinforcement required in each direction, that is 144 mm square. Now shorter span, that is LX, and longer span is, see, this is what, this is longer span. So in shorter span, the maximum bending moment at mid span and maximum bending moment at the end of span, this will calculated by the Excel sheet by default, and accordingly the reinforcement required in this region, that is 149.75 and 202.057 at the mid span at the end. But what we will do, we don't go for the mid span and end span, we combine it as shorter span. So we will take maximum of these two values. Okay, so maximum of these two values is 202.57, and the diameter of bar that we are going to provide as 10 mm. So what will be the spacing will be required? How we can calculate it? As for the 10 mm bar, the area of single bar is 78 mm. What it is? That is 78 mm. divided by 202. 202. If you calculate this value, will comes out to be equal to around 388.7. See, 78 divided by 202 multiplied by 1000. So 386. That is approximately 388.7. Okay. So what it means, for the diameter of bar 10 mm, the spacing required is 388.7, but the maximum permissible spacing for the reinforcement in the slab is 300 mm. So we have to adjust accordingly. So we don't go beyond the 300 mm. So we will choose the spacing as 300 mm in shorter direction. Likewise, the same calculation we need to do for the longer span. So we don't need to look at these values, we directly look at the diameter of bar to be provided. So again I am choosing the same diameter of bar, and the reinforcement spacing is 545. So we don't provide this much spacing. The maximum permissible spacing is 300 mm. So we will provide again 300 mm spacing. Okay. Now the last check is deflection check, whether the design slab is safe for the deflection or not. Okay. So we don't need to look at all these values, we directly concentrate on this result, whether it is safe or unsafe. So it says that the provided depth is safe in deflection. Why? Because span to depth ratio actual that coming on the structure is 32.579, that is, but the maximum permissible value is 54.92 mm. Sorry, this ratio is 52.929. So obviously the actual value that is coming is less than the permissible value, so our slab is safe in deflection. It may also occur that actual value is greater than maximum permissible value. In that case we need to revise the depth of the slab. So here our slab is safe for the deflection. Now the detailing part comes into discussion, that the main reinforcement will be provided along the shorter span, that is 3 meter. Shorter span is 3 meter and longer span is 4.5 meter. So shorter span, the reinforcement is 100 dia of bar is 10 mm at a spacing of 300 mm center to center, that we have chosen here. Diameter of bar 10 mm at a spacing of 300 mm along x direction. Okay. Now along y direction the same case is diameter of bar is 10 mm at the spacing of 300 mm center to center. Diameter of bar 10 mm at a spacing of 300 mm center to center. So likewise we will detail this slab. Okay. So this section of this slab, this main reinforcement, and these dots are the we can say distribution reinforcement or the reinforcement along the y direction. Okay. In case of two-way slab, both the reinforcements are the main reinforcement, remember. So this slab is detailed like this. Okay. So I hope you understand all this explanation. If you have any query, you can ask, you can contact me anytime. I have given the contact number in the description. You can WhatsApp me, you can call me, or by any way you can contact me. And if you want to get this Excel sheet, again you can contact me and I will definitely provide you this Excel sheet. Okay, so thank you, and please don't forget to subscribe this channel and don't forget to press the bell icon. Thank you very much.